between this guy and the guy you're seeing right now is, this guy now involves, it's still t distribution, but now it involves the difference between two sample averages in the numerator. So that's why this guy is at 0 in the middle. If there's no difference in the sample averages, that thing should come out to 0. Should place it right in the middle. But then you have to adjust it for the margin of error. And the margin of error, and I encourage you, if you're interested in why this margin of error is what it is, I've got a big write-up on the enrichment page about this. This is what the margin of error, and you'll never ever have to calculate this, just so you know. You'll never ever have to calculate this. It looks like this. That is the margin, that's the standard error, I should say. That's the standard error, where it used to be up here. This allows for both standard errors in both independent samples. So when you have one sample, it's pretty cut and dry, pretty straightforward. But when you have two samples, you have to adjust for the two samples error. And if you're interested in why, and you don't have to know this, if you're interested in why, I've got a write-up about why it is. Just realize, this is what's being done over there when you run two sample t-tests. This is that test statistic that's actually being done. I will never ever have you calculate it manually. There's too many places where you screw up. I screw up, I try to calculate it manually. And it heads full circle. Why you always put pooled for yes or no, you always put no for pooled? Because this is such a pain in the arse to calculate. What many, back in the day, before technology was as ubiquitous as it is, people were screwing this up left and right. So by pooling the standard deviation, what you're actually pooling in the test are the standard deviation. You're making the assumption that both populations have the same standard deviations. That's what the pooling means. So in other words, you wouldn't have two different one of these, you'd have one, if you will, average standard deviation. But that's dumb. We have technology now. Let it deal with that. So that's why you always put no on pooled. It'll do this for you. You'll never have to do this. Sweet Jesus, no. Sweet Jesus, no. If you care as to why this looks like, some of you might be sitting there and go, wait a minute, if this is subtraction, why is that addition? Some of you might be wondering why you don't subtract the standard deviation. Some of you might not care at all, that's totally fine too. But if you're interested, I've got a couple pages right up on the enrichment page that explains why it's added, why the error is added. Otherwise, just trust the TI, it's doing it for you just fine. It's doing it for you just fine. You don't have to worry about a thing. Cool? More of this on Thursday, and we'll also get into this guy here, which is the control group of percentages. Yes. And then we draw one more arrow next week. Yes. Yes. And it's our last arrow for the course. That's our last arrow for the course.